Hello, my name is Uzma Sayyed. This presentation is for MBA 6103 Statistic for Data Analytics. In this presentation, I will explain the overall data analysis process using two tools, R and JASP, based on the California Academic Performance Index dataset. The main goal is of data analysis is to turn raw data into useful information that helps with better decision making. For this analysis, I use the California Academic Performance Index, also called the API dataset, which we work with throughout this course. It contains school performance scores along with socioeconomic and education related variables. I will demonstrate two tools, R, which is coding based statistical tool, and JASP, which is point and click statistical software. Compared to Excel, these tools allowed more accurate analysis, better visuals, and more reliable results. Exploratory data analysis, EDA. EDA is the first step in data analysis. The purpose of EDA is to understand how the data looks before doing any formal testing. This box plot create in R shows the distribution of academic performance scores. It helps you see the overall spread, typical values, and how much scores vary across schools. This scatter plot, also created in R, shows the relationship between academic performance and socioeconomic status measured by the percentage of students receiving free or reduced price meals. We can clearly see that as economic disadvantage increases, academic performance tends to decrease. R is very useful at this stage because it allows flexible and clear visualization that helps identify patterns early in the analysis. Statistical testing, t-test. After exploring the data, the next step is statistical testing. An independent samples t-test was conducted in JASP to compare academic performance between year-round and non-year-round schools. The result shows a statistical significant difference, meaning the difference in average performance between these two groups is real and not due to chance. Non-year-round schools have higher average academic performance scores. Statistical testing, one-way ANOVA. When comparing more than two groups, we use one-way ANOVA. In this analysis, parent college education was grouped into three levels, low, medium, and high. The ANOVA result shows significant difference in academic performance across these groups. The means plot shows a clear upward trend, indicating that schools with higher parent education level tend to have better academic outcomes. Modeling and interpretation. To further understand this relationship, a regression model was created using JASP. This model predicts academic performance using parent education level and socioeconomic status. The model explains about 82% of the variation in academic performance, which means it fits the data very well. Modeling key takeaways. The regression result shows that higher parent education level are likely to higher academic performance, while higher economic disadvantage is linked to lower performance. This step is important because a regression helps us understand how strong these relationships are, not just whether differences exist. Now, R versus JASP, when to use each. R and JASP are useful for different purposes. R is best for detailed analysis, advanced visualization, and projects that require predictability. JASP is best for quick analysis, teaching, and presenting clean statistical result without coding. Using both tools together provides a complete and efficient analysis process. In conclusion, this presentation shows the full data analysis process, exploring the data, testing group differences, and building predictive models. Exploratory analysis helps identify patterns, statistical testing confirms meaningful differences, and regression modeling explains the relationship between variables. Together, R and JASP support strong, reliable, and data-driven decision making. Thank you for listening.